Hello everybody, this is Muhammad Kharsa from Chalmers University of Technology. Today I'm going to show you the features of my computer model which can be used to optimize energy retrofitting measures in building. As we will see in the following slides, this model concentrates on wall, windows and photovoltaics. The outline of today's video looks like as the following. I will start with introduction and motivation and the scopes of the work questions, explain the development model, examples of the results, and I will end with conclusion and future works. Let us start with introduction and motivation. As we all know that the indoor temperature during winter time is higher than the outdoor temperature, which means the heat transfers from inside to outside. To keep the indoor temperature at the desired temperature, we have to add to the building the same amount of the energy. While during the summer, it is opposite story. The indoor temperature is lower than outdoor temperature. Therefore, the heat transfers from outside to inside. Also, to keep the indoor temperature during the summer time at the desired temperature, we have to extract the same amount of energy. This amount of energy which has to be added to the building during winter time and extracted from the building during summertime called thermal load of the building. The thermal load of the building depends on indoor temperature and thermal resistance of the building shell, solar radiation, which means the direction of the buildings and how much it is exposed to the solar radiation, ventilation, in somehow the use of the building, how much fresh air must be added to the building every hour. Internal load, also if it is office, a lot of computers, or if it is gym, a lot of heat added by the people, or if it is residential house, so internal load and many other factors. As we will see in the following, we will talk or we will concentrate more on thermal resistance of the shell. As the part of current works motivation, we have collected some facts about building. In Europe, for instance, building accounts for approximately 40% of final energy used in the building. Compared to 1990, the European Union target 2020 is to reduce the greenhouse emissions by 40%, to increase the share of renewable energy by 27%, and to reduce primary energy used by 20%. Also, we collected some facts about the building in Sweden. Among the existing dwelling building in Sweden, 43% were built before 1961, 34% were built between 1961 and 1976, and about 23% of the existing dwelling building were built between 1967 and 2007. The buildings before 1975 were built to lower thermal standards than those imposed by the current regulation. So we are talking about 77% of existing dwelling building in Sweden were built to lower thermal standards than those imposed by the current regulation, which means that the energy used in this building is higher than later buildings. Unfortunately for the nature and fortunately for us who is working in energy field, 78% of the building built before 1975, no major renovation have been completed. So we are talking about 78% of 77 of existing dwelling building had no renovation at all. Consequently, the Swedish Energy Agency states that renovation can result in lowering the energy use in building built before 1975 by 70%. However, we are in Dream project aim to achieve 75% of energy demand reduction by implementing energy retrofitting measures. When we are talking about energy retrofitting measures, we mean two concepts. First, renovate the building envelope, and second, we increase the share of renewable energy. But what does it mean, each one? Renovation of the building By renovating the building, we mean adding insulation to the roof or adding insulation to the floor, adding insulation to the external walls, improve the window quality, and etc. In this work, we concentrate on adding insulation to the external walls and improve the window. The second concept of energy retrofitting measure is increase the share of renewable energy. The share of renewable energy can be increased by implementing wind energy or geothermal heat pump in the form of heat pump, or utilize solar energy in thermal form, or utilize solar energy for electricity generation. This introduces us to define the scope of the work. First, we start with the description, describe the building. No thermal load of from the floor or the roof. This means that we are talking about the apartment located between two conditioned places. In this case, when we are talking about renovate the envelope of the building, we mean improve the wall thermal quality and window thermal quality. So we don't talk about roof or building. How we retrofit the external wall? We retrofit the external wall by adding insulation in sandwich form. We have internal layer and external layer, and we add insulation between them. While retrofit the window is by selecting a window with a lower U value, so we can choose single glazing window or double glazed window or triple glazed window and different type of window. Regarding the second concept of energy retrofitting measure, which was increasing the share of renewable energy, in this work we will concentrate about utilizing solar energy for electricity generation, and the system looks like as shown in this picture. We have solar panel, we have energy or battery bank, we have converter, we have the load of the house, and we have utility grid. However, for a particular project, still major challenge is first, it is always difficult for a client to see the economic viability of retrofitting. The second challenge is the determination of the most effective retrofitting measure. This introduces us to the research question. Research question number one. We have a certain building with a certain thermal condition, certain energy demand, and we have a certain amount of the money budget, and the research question is what is the best use of this budget in my building. In another word, we have a certain amount of the building, and I need to know the best split of this budget on wall, window, or photovoltaic to maximize the benefit of these retrofitting measures. What is the optimal split of a given budget to maximize the economic potential of retrofitting? The second research question is the opposite scenario. I have a given condition of building, and the question is how much should I invest to maximize the benefit of my investment? In another word, I need to know how much should I spend on wall, how much should I spend on window on PV system, how should I spend on the wall. So I need to determine the budget, required budget, to maximize the benefit of my project, which it is retrofitting the building. What is the required budget to achieve the maximum economic potential of the project? To answer these two research questions, we have developed a computer model. The model has input window. In this window, we have different parameter to be inserted as a location and a lot of input. They are very easy to be found. We have some input regarding the specification of the building envelope, and the same things for the window. We have some input for the PV system, the price of inverter, the price of the battery, a lot of input regarding the building specification regarding the renewable energy system, and some input regarding the economic condition in the place. After we insert the input, we got a result as a table as shown here. We got a result regarding the heating load in kilowatt hour for in a year, cooling load, annual heating cost based on the COP of the efficiency of your heating system and the electricity consumption, annual cooling load as well, annual cooling cost, insulation cost. If you are going to put some insulation on the wall, how much it will cost you. Window grid retrofitting, if you will change some window to a better U value window, you need to know how much it will cost you, so the computer will give you the cost. Solar system cost, if you are going to install some square meter of PV panel and battery storage, so you need to know the system. Also, the system will calculate the cost based on the assumed area. Operation cost, how much your building will cost you for heating, cooling, and electricity consumption in a year. Life operation cost, for instance, if you need to know how much your bill will be for 10 years, for instance, so how much you will pay from now until 10 years for heating, cooling, and electricity. So this system will calculate the life operation cost. The life, you can determine it. In input, you have how many years you need to calculate the operation cost for. Payback time, after payback time of the investment, after you add some insulation or change window or you put some PV panels, you need to know how many years you need to get back your investment. Annual energy demand, how much your building will consume during a year. So this is as a result for a given case. After we get the result, also we develop for this model some optimization tool. You can optimize the budget to calculate the optimal design of the solar system, or you can optimize the budget or you can use the model to optimize the budget for insulation and windows, or you can optimize the given budget for solar insulation and window. Or you, the second research question, these three are to answer the first research question. For a given budget, what is the best use? The second research question is how much should I invest to maximize the benefit? So here we need to optimize the payback time and budget on solar, window, and insulation. The last calculation, you can calculate the system or optimize the system for different calculation for different budget. And the result is giving as a table optimization report. Based on which tool you use, you will get the report as shown in this picture. So this model will tell you how much insulation should be added to each wall, which window you have to change. This is the basic U value of the window. So this window, for instance, good enough. Show the computer tells you don't change it, but you have to change this one, and this one also good. So the only one to be changed is this, based on your available budget. For instance, your available budget is 15,000 as an example. So the computer will tell you how many square meter you have to add PV system, how many kilowatt hour the battery size should be. So it will tell you how many dollars must be spent on each element, wall, window, and PV system. Will tell you the payback time, after how many years you will get your money back based on energy saving. Will tell you the annual energy demand before, base, and after retrofitting, after adding this insulation, and after change this window, and after installing this PV system. You will reduce the annual energy demand, so you will achieve 52 based on this budget and this given condition of your building. You will get reduction 52. Example of some result, as we have seen, the computer give you a result in table. Also, you can get the result in figures. For instance, here we can see the share of heating load of the building during each month of the year. The same things for the cooling. Here for heating, here is for cooling. Also, we can get many different figures, the available solar energy and the output of PV system and the PV system efficiency. We can get many different. Here in this figure, we see the energy generation of PV system during the lifetime of the system. We assume the lifetime 25 years. So we can see the electricity generation, electricity use from the PV system, and the difference is the losses in the battery. So and this line is the losses in the battery. As we can see, the first year the battery in good condition, the second year the performance of the battery is less because the life degradation, and at the end, for instance, we assume the lifetime of the battery 9 years, the losses is the highest, and then we change it to get minimum reduction in the battery and so on. Also, we get cash flow of our investment, how much money I will get every after I invest in the money. So here we can see that I will get money, but in the ninth years, we have to pay some money for the battery. In 10th years, we have to pay some money for the inverter, so the output of the system is minus and so on. In the following slides, I will show you the optimization report for first research question and second research question. I will start with first research question. We have a certain budget, and we need to know how much I should spend on each wall to maximize the investment benefit. Here in this figure, for instance, I assume we have $10,000 for investment, and the U value of the initial U value of the wall as shown here, the initial U value of window as shown here, and I need to know how much should I spend on each element. For instance, based on my given budget and thermal condition of the building, I have to spend this much on the wall, this much on window, because I have to change this window because there is condensation. So this model can be used also to solve the condensation problem. Tells you where you have to put more money to prevent condensation. And based on your location and your electricity consumption, your budget, the computer tells you don't invest anything in PV system. So your energy demand before the retrofitting was this much, after retrofitting is this much, and the annual saving is 35. So by investing 10,000, according to your condition, you will achieve 35% of energy reduction, and the payback time will be a little bit higher than 5 years. This is another retrofitting optimization report. Here in this case, it is exactly the same case, but we assume we have more money. So the same U value of the window, the same U value of the wall, and I ask the computer to tell me the best use for this given budget among these three elements. Based on my condition, the computer tell me in this case to invest more some money in PV system. So I should install 10 square meter, and the battery I should buy battery of size 2.7. In this case, I will achieve 52% of energy demand, and the payback time of the system will be a little bit higher than this. We continue in the same in the first research question, but in this case, I assume we have 10,000 like the previous case, but there is no condensation on window. So I ask the computer, where should I spend my money? So the computer tell me based on the wall quality and window quality, I shouldn't spend anything on my window because there is no condensation. Instead, I should spend some money for a PV system. This is the case. We have seen it in previous slide. Here we have some condensation, as we can see. So based on this condition, the computer tell me I have to change this window from this quality to this quality, and I have to invest this much on window, nothing for PV system, and the rest is for wall. The payback time in that case, as we saw, about 5 years. Here, about 3 years. The reduction in this case, where there is no condensation, is 47. Here, where there is a condensation, I have to change this window, so the reduction is 35%. Now we move to show some example of second research question, optimizing the budget. As I show you, we need to know how much I should invest on my building and where should I split this money among these three elements, window, PV system and wall, to maximize the benefit of my investment. And here is some example for the same condition. We have just seen it in the previous slide. We have some condensation here. We have no condensation on the wall. And based on that, the computer tell me I should invest this much on window, on wall, this much on window, nothing in PV, and the total investment should be 11,400. So in this case, the payback time will be reduced compared to the previous case, as we just saw in the previous slide, where there is condensation and the investment. I assume that I have 10,000 I need to invest for retrofitting. The computer show me where should I spend this money, but when I ask him to optimize the budget, he tells me it is better to increase the budget from 10,000 to 11,400, and it is better to increase some insulation. Here, as we saw, based on the given budget, 10,000, I should put this much of insulation on each wall. But if I ask him to determine the budget, he tells me to put this much insulation. And the reduction in the annual energy demand will be about 44%, and the payback time is 4.9 years. Also, as we saw in optimization tool buttons, we developed tools to calculate the saving and the payback time for different budget to show the client how much benefit or how much reduction he can achieve for different budget. Finally, we come to conclusion and future work plan. Conclusion, the developed model can be used to determine the optimal use of a given budget to achieve a maximum economic benefit of renovation. Also, the computer model can be used to determine the required renovation budget and the optimal use of the budget to maximize the economic performance of renovation. Future work, as we saw in building description, we didn't consider the heat losses from the floor or the roof. So in the future work, I am planning to consider the thermal load of the building from the floor and the roof. It is quite easy, but I need to consider it in the future work. Also, I need to consider the direction, different direction of building roof. So I need to design the system for different azimuths. They're like if I have L-shaped building. So I have two direction. So I need to consider it on my model. It is not that easy, but it is not very hard. Also, I need to consider the thermal inertia of the building envelope, heat capacity of the building, and the mass of building envelope. Now, I don't consider it on my model, but I need to consider it. It is quite hard, but I will work on it in the future. Thank you for watching, and please contact me on the following emails for any feedback. It will be very much appreciated.